Let's consider the following application problem. The total sales as in thousands of games of a video game t months after the game is introduced are given by the function s of t equal to 125t squared divided by t squared plus 100. Find the derivative of s prime of t, find s of 10 and s prime of 10, and then interpret these results and use the results from part B of this example to estimate the total sales after 11 months. Now, to find the derivative of s of t, we use the quotient rule. S prime of t is equal to low, copy the denominator, the high, 125 t squared prime minus high, the low. Divided by low squared. Now, performing the derivative here, we have t squared plus 100 times the derivative here, which is 125 times 2 is 250 t squared. So 2 minus 1 is 1. So times t minus 125 t squared times the derivative of t squared, which is 2t, divided by t squared plus 100 squared. That's the derivative. So for letter B, we want to find s of 10, and also s prime of 10. So s of 10, that means replace t here by 10. So you have 125 times 10 squared divided by, this one becomes 10 squared plus 100. So 10 squared is 100. So 125 times 100 is 12,500 divided by 10 squared is 100. 100 plus 100 is 200. That gives us, so we can cancel the zeros here, 125 divided by 2 is 62.5. Now this 62.5 is the number of, is the total sales in thousands of games at 10 months. So this means 62,500 games were sold after 10 months. Next, we will compute s prime of 10. So to compute for s prime of 10, we just replace the t here by 10. So we have t squared, 10 squared, that's 100, plus 100, that gives you 200, times 250 times 10 is 2,500, minus 125 times 10 squared is 100. So 125 times 100 is 12,500 times 2 times 10. So that's 20. Divided by 10 squared is 100 plus 100. So that's 200 squared. And then just go ahead and plug this into your calculator. And after plugging this into our calculator, we get 25/4, which is equivalent to 6.25. Now this one would mean that the sales after the 10th month will increase, because this is positive, so it will increase by 6,250. And so to answer letter C, to use the results from part B to estimate the total sales after 11 months, we have total sales after 11 months. You have the sales on the 10th month, S of 10, plus S prime. So this is the increase in the sales after the 10th month. So S prime of 10. So our S of 10 is equal to 62,500 games plus 6,250. So this one is equal to 68,750. So that means the sales after 11 months is 68,750 games. Second example. The cost in hundreds of dollars incurred by a flower shop to produce X hundred flower arrangements for delivery on Valentine's Day is given by C of x equal to x squared plus 3x plus 18. Find the marginal cost at production level of 200 flower arrangements. So when you say marginal cost, that means the derivative of the cost function. So the marginal cost can be computed using C prime of x. So C prime of x is just the derivative of this expression here. That is equal to 2x plus 3. So just differentiate each term. And then to find the marginal cost at production level of 200 flower arrangements, you just have to evaluate the derivative of C at x equals 2. So y equals 2, because it is mentioned here that x is 100 flower arrangements. So this x is in hundreds. So 200, that means x is equal to 2. So evaluate the marginal cost, the derivative of the cost function at x equals 2. So you have 2 times 2 plus 3. 2 times 2 is 4 plus 3 is 7. So this means that at this production level, at production level of 200, the cost of producing an additional 100 arrangements is approximated by 700. Letter B. Find the average cost at a production level of 200 flower arrangements. So to find the average cost, you just divide the cost function by x. So therefore, the average cost is just equal to x squared plus 3x plus 18 divided by x. And we denote this by C bar. C bar of X is the average cost. And so to get the average cost at production level of 200 flower arrangements, we're just going to evaluate C bar at X equals 2. So this is equal to 2 squared plus 3 times 2 plus 18 divided by 2. And simplifying this will give us 28 over 2, which is equal to 14. So this means that at production level of 200 arrangements, the average cost is 14, and 14C is actually in terms of hundreds of dollars. So that means 1,400. The average cost is 1,400 per arrangement. So that's $1,400 per arrangement, per 100 arrangements. Next, we compute the marginal cost at production levels of 200 and 500 flower arrangements. Now, the marginal average cost is just the derivative of the cost function. So the cost function was equal to x squared plus 3x plus 18 divided by x. And then we will just get the derivative of this function, c bar prime. Now, to get the derivative of this, we can either use the quotient rule or you can rewrite this expression here. I'd rather rewrite the expression here and use the power rule. So let's just go ahead and divide each term by x. So we have x squared over x plus 3x over x plus 18 over x, and then simplify each term. X squared over x is x plus 3x over x is 3, and 18 over x is also equal to 18x to the negative 1. And then differentiate each term here. We have the derivative of x is 1, derivative of 3 is 0. So 1 plus the derivative of this is negative 1 times 18 x to the negative 2. And simplifying this is just equal to 1 minus 18 over x squared. So and now to find the marginal average cost production levels of 200 and 500 flower arrangements, we are just going to evaluate the derivative of the cost function at x equals 2 and at x equals 5. So this is equal to 1 minus 18 over 2 squared. 2 squared is 4. And simplifying this using your calculator, you get negative 3.5. So this means that at this production level, if an additional 100 arrangements are produced, then the average cost will be decreased. This is negative, so that means it will be decreased by approximately 350 per 100 arrangements. So again, it's decreased because it's negative, and then 3.5 will be multiplied by 100 because this is in hundreds of dollars. So that means this one, if you interpret this, you would say that the average cost will be decreased by approximately 300 per 100 arrangements. So similarly, to get the marginal average cost at production levels of 500, you have C prime at 5. So that means you replace x by 5. So you have 18 over 5 squared. 5 squared is 25. Now simplifying this using calculator, we get 0.28. So since this is positive, that means an increase. Now before you do that, you multiply this also by 100. So 28 by 100, that means 28. 0.28 times 100 is 28. So this means that at this higher production level, so at 500, the average cost will be increased. So this is positive. It will be increased by approximately $28 per 100 arrangements. So and again, to reiterate this, 0.28 will be multiplied by 100 because this is in hundreds of dollars, and then we'll interpret the result as that the average cost, so this is the marginal average cost, so that means that the average cost will be increased by approximately $28 per 100 arrangements at production level of 500 arrangements, flower arrangements. Now lastly, we want to find the level of production at which the marginal average cost is 0. So therefore, to compute this, we will just have to set the marginal average cost to 0. Now our marginal average cost is 1 minus 18 over x squared. You set this to 0 and you solve for x. So if this is equal to 0, then we can just move this to the other side of the equation. We have 18 over x squared equal to 1. So if 18 over x squared is equal to 1, that means 18 is equal to x squared. And so therefore x is equal to plus or minus the square root of 18, which is equal to 3 plus or minus 3 square root of 2, or approximately equal to plus or minus 4.24. Now, since you cannot make a negative number of flower arrangements, so you just say that x is equal to 3 square root of 2, or 4.24.